Hello everyone, welcome, and today we're going to be covering digital certificates and digital signature. And this is part of the computer A-level syllabus. So initially, let's just see how digital signatures work. And this is based that you already have understanding from AS level, where we cover digital signatures and certificates. So just like a little recap, the message together with the digital signature is encrypted using a sender's private key. And we'll see about generating digital signatures later. But just generally, they work by we encrypt the digital signature and the message together using a sender's private key. So if I am sending it, I will encrypt it using my private key because I only have access to it. Then the digital signature is sent with the data and it is decrypted with the sender's public key to record the message that I just sent. So what we know is here, when we are using digital signature, we have a hashing algorithm, right? We'll discuss this later on too. We have a hashing algorithm, and that hashing algorithm is used on our message to produce a fixed value. So even if it's one word, which I'm encrypting, or 10,000 words, the digital digest will be the same amount. And this digest is known as a digital signature, and this is encrypted, and this is decrypted here to recover the digest. And then the decrypted message is also hashed again using the same hashing algorithm to reproduce a message digest. So if I'm hashing ABC at the start, I would produce something like 1, 2, 3, 4. That would be my hash. Now, if I decrypt it successfully, because that can only occur with my public key, I can successfully decrypt it, I would get ABC again. And that algorithm would then again produce 1, 2, 3, 4. Right? So when we compare the two digests, if they are the same, the message has not been altered, right? And if they've been different, they're being altered. So there's someone in the middle who's changing the data. So if you look at this image, I am person A, I'm sending hello. I'm using my private key and I'm producing a file which is encrypted, which is not encrypted, it's sent along with a digital signature. It is again unlocked, I guess, with the public key, and they're compared, and then you get hello. Now, how does this checking actually work? So just a bit more detail. So how is a digital signature produced beforehand? So firstly, the message is hashed with the agreed hashing algorithm to produce a method digest, which we talked about, right? The method digest is encrypted with the sender's private key to form the digital signature. So when I pass it through here, now I have my digital signature. Sorry about that. And now I have my digital signature. And now, how can it be checked when I receive it? So the message together with the digital signature is decrypted using the private key. Sorry, this is incorrect. This is public key. And here, I'll just rewrite this. Public key. And then the digital signature received is decrypted with the sender's public key. Yeah. Oh, sorry. So, I see the error here. This has just been changed. This is the same as the stored. It's encrypted. Yep, okay, awesome. And this is the same thing to recover the digest message. And the decrypt message is received is hashed with the agreed hashing algorithm, produce a digest that's been received, like we discussed. Now, more importantly, related to websites, we have digital certificates. A digital certificate is an electronic online document that's used to authenticate the identity of a website or an organization. So imagine I am going to, let's say, Amazon, right? I'm going to their website and hey, I want to make sure the person who I'm talking to is actually Amazon. It's not a scammer or a hacker in the middle trying to steal my data. So this is where we use digital certificates. All right, and this is issued by a CA. A CA is known as a certificate authority, and we'll discuss that later. And for example, it contains information identifying a website's owner and a public key. This is in the digital certificate. So if you imagine here, I have the certificate authority, which is issuing the certificates to certain people or companies, And the digital certificate is used to verify the identity, and it's used to provide a public key. So when we're using digital signature, remember, we're encrypting it, right? And we can decrypt it using the public key of that, or during encryption, not digital signature, sorry. And this contains the person, the digital ID, and the expiry date. Yeah, like that. Now, how does one acquire a digital certificate? So, the organization or person will request a certificate from a certificate authority. So, these are like the high level people, not Google, but there's others like Let's Encrypt that allows you to get certificates. And the organization may have to send their public key to the certificate authority. And firstly, the organization gathers all the information required by the CA to obtain their certificate, which includes information to prove the identity. So obviously, you want to make sure it's secure, right? So I need to provide information like, hey, my name is Jeff Bezos. I am the person. I want a certificate for Amazon. And the CA will verify my organization's identity, and then it will generate or issue a certificate including my public key and any other information. So if you go to any browser such as YouTube, and if you click on this golden icon in anything, you can see that your connection is secure because we have a valid certificate. So over here is issued to rapid web services, and then you, in that case, in YouTube, you see it's issued to YouTube or Google. So that's just to make sure, hey, they have a valid certificate. Now, the role in creating a digital certificate. The digital signature in creating the digital certificate. So the digital certificate will provide the public key. So this can be used to validate the private key associated with the organization's digital signature. So if the organization is sending me a message, so Amazon's sending me a message like, hey, we have confirmed your delivery or whatever of your Nintendo. So what it will do in a digital signature is it will use its own private key, which it won't share, and then I can use a certificate authority. Using the certificate, I can use that public key to decrypt it, and then I can make sure, hey, this is correct. Awesome, right? So that is everything we had to cover for digital certificates and signature. This is a very easy topic. It does get tested quite frequently. It comes once, maybe every year, so October or May. So it's definitely a topic you can't skip. Alright, best of luck, guys.